Okay, Algebra 2, we're going to look at transformations of cube root functions today. Remember, this is going to be the parent function f of x is equal to the cubed root of x, and this is what your basic parent function graph looks like. Transformations work the same for cube root functions as for any other. If you add a number at the end, it's either going to go up or down. If you trap a number inside and add or subtract, it's going to either go left or right, and it's going to do the opposite of what you would expect. You're going to have stretches and compressions and reflections based on numbers in front of the entire problem or in front of the x but under the square root. Once again, they all work the same as everything we've learned before. So if you went from the cubed root of x to the cubed root of x minus 3, okay, the cubed root of x minus 3, what do you think would happen? It's trapped, so it's horizontal. It does the opposite of what you would expect, and so it's actually going to go to the right 3. If you had the cubed root of x plus 3, once again it's trapped inside, so this one would go left 3. So see, here is your parent function, and basically, would you not say that for the first one, every point is 3 to the right of where the original point was? And for the second one, every point is 3 to the left. So there's your proof when you look at the graph. Okay, going to the next page. We're going to look at these and just say what would happen. Okay, I have a number in front of the whole thing, so that's vertical. It is bigger than 1, therefore it is a vertical expansion, otherwise known as a vertical stretch, okay, by 3. The other one, we've got a negative, okay, so that makes it flip. It's important that you know what it flips over. It flips over the x-axis, and it's also going to have a vertical expansion by 3. The negative and the 3 cause two different things to happen. So the first one, they just had an expansion. It just kind of got steeper. The second one, it flipped and is going the other way and is steeper. So we have a number in front of the whole thing, but it's smaller than 1, so this is a vertical compression by 1/4. This one is going to flip over x, and you once again have a vertical compression of or by 1/4. And this is what your graphs would look like. Going to the next page. Several pages of notes, but they go pretty quick here at the first. Alright, so basically, I'm not going to ask you to graph anything, so don't worry about that. Basically, you're going to look at it and tell me what's happening. Alright, it's inside, so it does the opposite of what you think. It is in front of it, so it's got to be a stretch or a compression. It is a small one, so this is a horizontal expansion by 0.5. This one is going to flip, but this time it's going to flip over y because it's trapped in there, and you have a horizontal expansion by 0.5. We have a number in front. It's bigger than 1, so it's going to be a horizontal compression by 6. This one is going to flip over y, and you still have a horizontal compression by 6. Going to the next page. So I'm not really worried about what is the graph. I just want you to look. I don't care that they're talking about a cafe or whatever. I'm worried about the numbers and what's going to happen to my graph. One thing at a time. This 2 is going to be a vertical expansion by 2. The x plus 1 in there is going to make it go to the left 1. And then the plus 4 at the end is going to make it go up 4. So all I want you to do on this is just list the transformations. So the first one over here has a plus 3 at the end, so it's going to go up 3. This one has a minus 3 at the end, so it's going to go down 3. This one is going to go to the right 2.5. This one is going to go to the left 2.5. At the bottom, we have a 4 in front. That is a vertical expansion by 4. Over here, we're going to flip over x and have a vertical expansion by 4. This last one on this page, we're going to have a vertical compression by 0.5. And the last one, you're going to flip over x and have a vertical compression by 5. Going to the next page, we have a 1/3 x on the inside, so this is horizontal expansion by 1/3. It's expansion because it does the opposite of what you would think. This one is going to flip over y because it's trapped in there and have a horizontal expansion by 1/3. Here you're going to have a horizontal compression by 2, and then the other one is going to flip. Once again, it's over y, horizontal compression by 2. This one has a lot going on, okay? Now what about this 3 at the beginning? You got to think, well, what if I moved it to the end? Would it not be the same thing as saying plus 3 at the end? Okay, so the negative makes it flip over x. The 1/2 gives you a vertical compression by 1/2. The x minus 2 is going to send it to the right 2. And the plus 3 at the end is going to send it up 3. So you got to understand that you just move that 3 to the end. On the next one, we have a plus 2 in there that's going to send it to the left 2. Minus 5 at the end that's going to send it down 5. We're going to omit the next one. Moving down to number 3. We have a 0.9. It's not a fraction, but it is a decimal. Therefore, that is a vertical compression by 0.9. Be careful. Don't let that trick you. Minus 3 in there is going to send it to the right 3, and plus 2 is going to send it up 2. So then they ask it a little differently. What is the relationship between a, the cubed root of x, and negative a cubed root of x? Okay. Well, you got to realize that this one is going to flip over x. Going to the next page. This has you to the assignment, so you're through with your notes. You can get your assignment and get started on that.